Okay guys, this is a crash course on a CarSim, an application of the steady state handling analysis with use of this software. I should mention that this is not a kind of official course from CarSim, and if you see something wrong or you couldn't understand it, you just consider your method. And this is unofficial training. So to start with, you just go click on a CarSim. It will show you a different database you could select. I think by default you will have, depend on your CarSim version 2016 or 17, there is a default sections. It will go and try to acquire the license based on the package you have. It will take a while. Okay, so then you will see that you have a list of the license. It will be quite different based on your software and the license you have. So if you see the software, the first page you will see depend on the previous experience you had. It could be different, but generally the package could be divided in three major parts. The place that you define your properties, you run it, and then you see the results. There is a part usually related to, if you open a base model, you will see some description about the model, the test procedure, and so on. So the major advantages of the CarSim as a multi-vehicle system dynamic software is a huge database. You will have access. If you have some experience, you may know that small details or very major details like tire properties, mass properties are sometimes very challenging, and if you don't have enough experience, by selecting some wrong values you will have a very odd response. And this package could serve you a very good uh, reference for very primitive analysis, with the one we are going to do, which is a handling analysis and steady state analysis, to accident avoidance, or even some advanced methods like ADAS or autonomous vehicle, or uh, testing your AI approach for automotive driving. What I am going to do in this quick course or tutorial is a steady state handling analysis. There is three different types: constant radius test, constant speed test, and constant steering test. Different method, different approaches, and sometimes reaching to different values. As engineer, you should go always for a conservative approach, or understand why you are selecting a specific test with respect to others. What we are going to do is doing a constant radius test here and finding if the vehicle is understeer, oversteer, and maybe I will give some additional part for you to do, like question wise. So if I wanna make a baseline for you, you go for this ISO steady state circle with 100 radius curve. The main concept you may understand is, and you should keep in mind, as you always have a lock sign here, which is good part because you can do a lots of things like seeing the results without touching anything. There is option by clicking here and unlocking it. I don't recommend it. Its best approach is, I think, you keep your database as much as you can intact, and try to build based on it. So maybe the best thing is you have something you trust on, you duplicate it, and I will give it a kind of specific name to it. #1. You will have this one, then, and you see that's unlocked. You can go through the details and start to change the parameters. As I told you, the specification of the test could be classified as the vehicle itself, the road you are testing it, and the scenario that you are putting on the test. So I'm clicking on the first field here, which is giving you information about the vehicle. Could be sprung mass, if the vehicle is subject to aerodynamic forces, what is the shape of it, which is kind of graphical point of view, the powertrain, braking system, and the tire. Then you may notice that this is a locked database. I don't want to unlock it. I will go and duplicate it, give a name to it, and this is unlock. What I will recommend you to is going to the back, going to the base dataset, and you may notice that this is not automatically selected. You should click on here, go to the B class, and find your database related to the vehicle configuration and select. It's the best approach to do it because software is not automatically checking it. Maybe there is another way of modification that do the automatic assignment of the model, but maybe I'm not aware of. Then what I'm going to do is selecting or modifying the sprung mass property of the vehicle. If you click on it, you will see that this is a vehicle you have, and for now we assumed it's as a rigid body, sprung mass property, moments of inertia, radius of the gyration, and so on. This is again on a locked system. I'm clicking back, and I don't have anything. You see that you can define any other software since we want to have a space model. Let's go for this, a B class model, duplicate it, give a #1 here, and I'm duplicating it, going 2 times back, reaching here and going and selecting the one I want. So this is unlocked. If I change it, it will be changed under the unsprung mass properties of the B class car dash or #1. So what I want to go and do is changing the CG position. This is serving you as a very good example of the B class sport car, which is CG position is a bit rearward. What I want to do is changing the distance of the CG with respect to the front axle, 965 here, and then the height of the CG here is 425. It's a bit higher. I will keep this one the same. I will keep this one the same. So the things we are changes the height and position of the CG. You may notice that some parameters here are just working for a graphical point of view, like the way you define the envelope for a vehicle to make animation around it, all of the units in millimeter, and the total CG of the unsprung mass is here. What I'm going to you and recommend you is taking a screenshot of this one, because for one of the questions you may need it at the end of the tutorial, you may need it to use it. And maybe bear in mind that the reference coordinate system is assumed on a road and passing through the first axle. So I'm checking this one. This is the one I selected. I don't want to have any complicated things of the aerodynamics, so I'm going to select it no aerodynamic, as you can see here. So there is no aerodynamic effect. If you want to see, go and select and read about it. Fortunately, the software has a very detailed help, which you can learn a lot by reading a bit. So, which I'm recommending it. Then, is related to the powertrain. This part is shape of the car. You can define what you want. You go through the hub. You can see how to define it, how to make it the tire shape, and these kind of things. I really don't want to spend too much time on it. And going through the system and powertrain, this is a sport car, and we want to have a front wheel drive. Good. Then I go through here and select 125 kilowatt 4.1 ratio. So these are clutch and the power of the engine. Maybe again, if you want to see based on your project in SAE formula, you can define what you want. The braking system, for now I don't touch it because I will not define a method for doing braking. Then but anyway, I will define this one for now, which is already selected. The next step you should do is going through the front suspension here. Sorry. Yes, here. I'm going back again here to show you what's happening. So I have a front suspension and rear suspension kinematics. So in the rear, the distance is 1 meter, 485 millimeter for the rear. And as you can see, 5 millimeter different between front and rear, which is again kind of default for sport car and staggered tire approach. Anyway, what I'm recommending you is taking care of this one and recording the uh, wheelbase track of it. Given that, maybe I will try to show you the tires, which is here. And you may understand and know that the performance tires are kind of critical to find the data, or maybe depend on the chance you have, you will have a test center for giving you this kind of values. But anyway, for now I will just trust the values provided by the CarSim. As you can see here, by clicking on it, you don't need to unlock anything. You will see a very detailed information about tires, and as you can see, tires is a kind of generating the performance for you in longitudinal, lateral and vertical direction, which could be a function of the camber, caster, and even normal load. So if you want to do a braking analysis, you can see that this is a braking performance test you can have. You simply click here and extract everything to a Excel sheet or import it here. The way you read this one is up to software, but as an engineer you should know what is going on here. This first column is related to slip ratio because it's a longitudinal performance of the tire. The first column here, as you can see, which is color coded, is the vertical load on a tire. And just generally, if you have more load on your tire, you will have more performance. And these values are the load on each individual tire in Newton. So what the software is doing is based on the algorithm. You may know that there is a different load shift based because of the longitudinal lateral acceleration. Your load could be between these two values. It will interpolate, and then based on the slip ratio, it will generate the longitudinal forces generated in a tire. What you need, since we are going to do a steady state analysis for handling, you need to have this one. If you click on it, it's a tire 205 R17, the way you read regular tire size. Export it to Excel because I want you to try to use the result of the software, this graph and the load distribution to find the C alpha and K understeer of the vehicle for as a validation or better understanding of the model. Again, The longitudinal axle is a slip ratio here in degree, and this is normal load. So this column is vertical, slip ratio. This first column is normal load on a tire. Higher normal load, better grip on a road in a very regular way in Newton. So if your model is something between these two graphs, software will try to instantaneously find a corresponding value between based on a vertical load uh, for a given slip angle, generating or finding the grip force for you. So I recommend this one to export it to Excel and save it somewhere, which I don't want to spend too much time on it for now. Maybe I will go back here. Then the next thing you should maybe record for your information is the track width, which assume this one as 1 meter and 480 millimeter. Then I think for now this is your model, and yes, this is Excel file. You simply record it, and as I told you, slip angle in degree, Newton forces, normal loads, and these are the creep lateral loads. What I maybe recommend is this one. Insert a column, and as you know, everything is starting from zero. There is no bias or something around here. So let's say what we have based on the load, you will have a load here with something around, let's say, I don't yet calculate it, but Newton for one tire in front and differently in rear, and you interpolate between these two values, a linear interpolation to find it. There are some codes in MATLAB, in Excel to find it for you. So when you have a force, you try to find the C alpha. C alpha is linear, and you should know what's the linear range of the force. But anyway, for now, I think that's enough. I will upload a PDF related to the everything related to this tutorial in a description soon. Then let's go for a procedure. In procedure, we want to do a constant speed test, which I'm clicking here. I am unlocking it by duplicate. Yes, go back. Oh, sorry. And go back here again, home, and try to find the procedure here. Click on it. I want to test something with 100 kilometer per hour as the initial speed, and I will call it constant target speed. It's a bit different comparing to this one, so it's a kind of rate displacement or respect to the time or this position. Then you don't do any braking. I don't change it. You don't do any shifting. Actually, do the shifting. Let the software do the shifting, gear change for you. And this is a driver model. It's valid up to 15 km per hour. And again, I'm recommending you to go and read it about it. It's a preview path. Like generally as a human, you go when you sit on a car. As a driver, you look forward and estimate your position and try to compensate the error. So you will say you don't have any offset with respect to the center line of the road. You just look in front of you by 20.25 seconds, which is very general value. which is previewing it, and it's valid for a while, for 50 km per hour. Highly recommended to go and read about it in help, because usually some of these controllers are not really human, and it's a big major research topic to simulate the human reaction in this kind of softwares. Then we should define a road we want to test. So here the software is doing specifically by a coding. I don't want to go like that for you, it's too much for first experience on a CarSim. What I'm recommending you is going to here, trying to find path and road surface, going to 3D surface, clicking here, and then go to handling road, and then go to yes. So technically you can select whatever you want from this list, even a railroad crossing to a highway merger, and even a test rig center for when you put your car on a test rig. What I think is best for now is going for this one, clicking on it, duplicating it, and going 2 times back before forgetting it, and trying to select it here. By clicking on it, this is our unlock method. So what I'm going to show you is the road that we are going to use as a constant radius handling analysis set. What we are going to do is making or checking that if the tire segment is 100-meter radius, as you can see it is, so there is no need of changing it. It's a flat line track, which is okay. Then this one is a friction coefficient for you, which is 0.9. 0.9, you may understand that this is not that much a big or realistic friction coefficient, but it could be. So it could be very important to understand it. Why? 0.9, you know that this is not a real value for you, but if you go here, click on a home, go here, and you remember that when we got this one, the tire properties, you have a vertical load and corresponding vertical load. You see this is kind of a jump between these two, which is kind of related to friction coefficient you had in a test rig, either in a road, in a way you measure it. So it was a kind of concrete or a gravel or whatever. The device, the measurement system, or the company provided this value to you, measure it and give it to you. We put here tire road friction coefficient at 1. I think it's very important for you to look into these values as a scaling factors. So you have a 1 over there, which is in fact there is no weighting or changing in a friction coefficient measured in a reality for generating those graphs. We just saved in Excel, but you could consider it that when you were testing this method, it was a rainy day or it passed the rain. So again, these things, usually if you go for 2.5, it's like ice condition, because you are scaling down the everything by 25% lower. So the rest of these things you can see here are actually, sorry, I should click, I was in the wrong place. So the most of these things are related to the, like this coefficient here, they are something you should take care of it personally, as you can see, and you don't have any 25% here. which you usually think the friction coefficient are. So it's an indirect friction coefficient consideration in your simulation. So for now we set up something, and you can define something like trees, skyline. These are just graphics. Even if you click on this one, it will try to open a preview of your road. For us it's not important, but you can go to crazy detail, as you can see, and you can just try to do as much as you can. You can even couple link it to Unreal Engine, so there is a vast area you can indulge in and learn if you want to stay in a field, specifically with CarSim. So we did this simulation, but there are some tricks that you should understand in all of your experience as an engineer when you do virtual testing and virtual simulation, that you should understand the software is doing. Sometimes it's doing it very simple for you. So if, for example, I will go back here, and here is a vehicle property, nothing very special. So we define as much detail as want, but when you don't use it like braking scenario here, uh, it won't do anything for you. It will be biased. So just bear in mind that sometimes these things, if you work with the default, it's always good to use it, but they are serving specific scenarios for you. So this one here is doing a very long test, which is checking a specific Ackermann even values for you and so on, which for now I will put it up to you to go further and read it, but I will click on it and say it no, nothing. What I'm going to do also here is I'm stopping it at 400 meters, and the plots are here, but there is another way that you can define a specific plot for you here. After I run it, you can do it, and let's see. Again, this may be interesting for you. Maybe I just even confused. That you define here the road, sorry, for yourself. And there is also a chance here to define the road. So I think the hierarchy is this page. Whatever you define here, you can set it up to don't control any to overwrite whatever you define under it. Sorry, here like I have defined the road here, and here is saying there is also a tire property. You will get it by some try and error, so just don't trust actually the first result you get. I'm clicking here and trying to run it. So what was the test scenario? Passing a radius or 100-meter radius curve with 10 km per hour speed. It is a bit slow, which in fact it's not, because it's actually faster than real time. But I defined a very long simulation. And what was the reason? You just go here. What it's saying here is I want to run it 400, which is not needed. Good. Back here. Great, you have the results. If I click here, these are the simulations results for you. Maybe too much, because this is reading all of these guys here. Maybe I don't need it. So I'm going to define maybe 4 plots, and I will ask the software to just show me these plots. So as I told you, I'm going to set up 4 plots. I want to have the longitudinal speed, and I go to vehicle motion at the end and try to find longitudinal speed to see if I'm reaching really that speed or not. Then going here and vehicle motion lateral acceleration of the CG position. Then I want to see if my steering angle is fine and use it to see K understeer and K oversteer. Steering wheel angle, go to steering, steering here and select road, steer wheel angle. So steer wheel angle is this one, okay, versus station. Or maybe you will have it, just give me a second, try to find it. No, there is nothing here. So maybe if you click here, you will see it's reading the steering wheel station. What I will do is duplicate it and change this one to time. I think it will work. Back here, 2 times. This is not selected, steering, and here you are the guy you want. And again, steering. So if I select this one, you see all the steering angle with respect to time. So the first one here was lateral, longitudinal, lateral acceleration, the steering wheel angle, and the next one is the steering angle you will see on a road. Perfect. So if I click on a plot, since the software is already compiled, you will have 4 graphs, very good and simple. Then you can use the software to read the values, which I will give you a kind of idea, but maybe before that you have a chance of seeing the results. So I will just give you some simple examples, like I will select the default value. So this is a driver point of view, nothing very fancy. So the driver actually looking 0.25 second, 25 second, 250 millisecond in front of it, in front of the car, and try to minimize the error. I will try to maybe go for vehicle fixed camera, and that's not bad. View. So this is the one you want to see, and maybe for now just push F1 and you will see a list of shortcuts. The cursor, if you rotate your cursor, it will make it faster or quicker or slower. But for now, that's fine. I will close it. And if I click everything together, you will have the everything with each other. So as I told you, you can plot all of the results you want to see. Spacebar, I think it will stop it. Yes, if you push a spacebar, it will stop it. it will go as usual and getting a steady state value. So what you can do is exporting, finding a way to exporting. This is up to you to maybe as assignment how to export the result from CarSim to something like Excel. Then you maybe before that you just click on it and push V. As you can see here, you will see a value here, V also, and V. So I gradually getting to a steady state value, which as you can see is 10 kilometer per hour. Here there was some fluctuation that was not as very important. This 10 kilometer per hour, which is indicated here, generating 0.0078 g lateral acceleration, kind of related to the radius of the 100-meter. Here as you can see, for staying in this radius I should generate 19.8 steering rotation, and steering ratio you already know, it will generate small root angles on the tires. A ratio small value you can see here is because of the kinematic of the suspension system in rear of the and front, and it's correspond to 1.5 1.3 left and right. Okay, so this is the first one. Just make a simple table for yourself, record the longitudinal speed, corresponding lateral acceleration, the steering wheel angle, front left and front right steering angle in degrees. Just record it. So what I wanna recommend you is just test it for 10, 35, 10, 35. Let me just do it for fun. Go back here and run. Plot the results. Go for V, 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 and V. What's the speed? 35. What we want? 35. The driver should steer more. The lateral acceleration is getting point quite higher, at least. It was 007 and now 0009. Steering angles. Go for something higher. What I recommend you, we did 10, 35. You do for 50. You do for 70. And you do for 90. I will just run for 90 for now for you. And let's run it. Let's plot it. And still stable. 90 kilometer per hour. Lateral acceleration is 0.6 or half a g, which is kind of very interesting and good. Steering angles are nice. And 32. If I want to see the videos, you can see that what is happening here. With just as usual, F1, left mouse is reserved, it's not doing anything. If you want to rotate the camera, right mouse click. You want to scroll, middle mouse and drag and so on.